All right. So the problem we have is quite an interesting problem. Unlike other problems, we have two projectile motions combined in one equation. So two guns situated on the top of a hill of height 10 meters fire one shot, each with the same speed of 5 or 3 meters per second at some interval of time. One guy, sorry, I'm sorry. One gun fires horizontally and other fires upwards at an angle of 60 with the horizontal. The shots collide in air at point P. So let's draw the situation here. So we have firing something from a height of 10 meters from the ground level. Uh, one is fired at an angle of 60 to the horizontal. So let's say that is 5 root 3 meters per second and the angle is 60. The other one is fired horizontally with the same speed, right? So we have another particle that is fired horizontally with the same velocity 5 root 3. So this one is going to come like this, and the other one will travel up and it will come like this. I do not know. Let's say this is the point P where both of them meet. So that is going to be a ground level. So that cannot be 10 meters because it has to be some down, right? So let me kind of bring it down further. So that is 10 meters. And I do not know at what height they are meeting each other. Let's say they are meeting at a horizontal distance of x naught, and they are meeting at a vertical displacement of y naught. The shots collide in air at point P. We have found that. Find the time interval between the firings. So for the yellow one, let's say that the horizontal projection is this, right? So this 5 root 3 cos 60, that is going to be a horizontal component of the velocity. So 5 root 3 cos 60. So 5 root 3 cos 60 is going to be 4.3 meters per second. And that is going to meet, or that is going to travel a distance of x naught. Meanwhile, the other particle is going to have a velocity of, let me use a different color, not to confuse with both particles, right? The other particle, my bad. So other one is traveling with a velocity of 5 root 3, and that other one is also moving the same displacement of x naught, but we do not know what that x naught is yet. Meanwhile, this particle is going to travel to the point P straight down. The velocity component in the vertical direction of that is going to be 0. However, the other one is going to go up and then come down. And the vertical velocity is going to be 5 root 3 sine 60. So sine 60 is 3 by 2, so it is 15 by 2, so 5 meters per second, right? And both of those particles are going to cover a vertical displacement of y naught. So 5 root 3, the horizontal component of the particle is 8.7 meters per second. In this question, so you should understand that two particles are not fired at the same time. So one particle has fired initially, and then after a while, the other particle has been fired. So which is fired first? So if we compare the horizontal projection, one has a greater velocity than the other one, right? So one is 8.7, the other one is 4.3. So the one with the highest velocity should have been fired later than the one with the lower velocity, because lower velocity takes more time to travel the same distance, because both the particles are traveling the same horizontal distance, right? So the one with the lower velocity should have been fired first. So the one which makes an angle of 60 fired first. So let's call it t equal to 0. And the other one has been fired at t equals to t, right? So let's call it t equals to t now. So the first one should have been the one that is making an angle of 60 should have been fired at t equals to t naught. And let's say the other one has been fired at t equals to t naught. And both of them are meeting at t equals to t. So the second one must have had a time of flight, which is this one, right? T equals to t minus t naught. And this one should have a time of flight of t equals to t, right? So this is your time of flight. So we can use the horizontal projection for both the particles, right? Horizontal projection. I'm going to use delta x equals to vit plus half at squared in the horizontal direction. So for the first particle, it is 4.3. Initial velocity is, sorry, it is x naught. Initial velocity is 4.3, and the duration of flight is t plus 0. So that is my first equation. And the second one is also x naught, but it is 8.7, and the flight time is t minus t. That is my second equation. So let's keep it as it is. And I'm going to use the vertical projection as well. Let's write all the equations and see how we can solve, because so far what we have is 3 unknowns and 2 equations. So we understand that if we have 3 unknowns or more unknowns than the equation, or less unknowns than the equation, then we are not able to solve it. So we need exactly same number of unknowns and equations. So I'm going to use the one that is fired later on, which is the one that is fired horizontally, so that I do not have to deal with the vertical velocity, right? So I'm going to use delta y equals to vit plus half at squared, and I'm going to use it in the downwards direction. So the first one doesn't, so travels a distance of 10 minus y naught, right? That is equals to initial velocity 0 plus half acceleration due to gravity. I'm considering it as 10 and t squared. So let's keep it as it is for the time being. Let's not worry about simplifying at this point. So now that I have 4 unknowns, I need another equation. So I'm going to write it for the second one as well. So that has also traveled. So that is not y naught. Okay. That is not y naught, right? Y naught is down. So that is 10 minus y naught. Like that. 10 minus y naught. So the second one is also 10 minus y naught. I am considering down as positive. I have an initial velocity of 7.5 in the upward direction, and t plus minus 7.5 because it is up, minus half times 10, and the time of flight is t. So this one, the time of flight is t minus t, no? So that is not going to be t. So that is t minus t naught square. So that is my third equation. That's my fourth equation. Any doubts up until this point?